We are going to sketch a graph and its inverse. We're going to sketch a graph of this function. And notice I'm not asking is it invertible, I'm not asking is it one-to-one, I just want to sketch the graph and its inverse. So, looking at this, I know that this is going to be a parabola. And that means it's that nice U shape. Could be going up, could be going down. We'll find out what happens with that. And either you might be able to look at this and just recognize the shape right away, or you might need to make a table. I'm just going to make a quick table to graph these points. So I'm going to run x, y. I'm going to run my x, my inputs from -2 to +2. I'm doing that with the hopes that I'll find the vertex. I'll find the minimum or maximum point with this. If I don't, I'll add some points and see where we end up. So let me plug some stuff in. I'm going to take this -2, plug it in for x, do some arithmetic. It's going to spit out a y. 2 times input, it happens to be -2 squared, minus 3. So -2 squared is +4. 2 times 4 is 8. 8 minus 3 is 5. So when x is -2, y is 5. So now I'm going to use a different input, but the process is the same. So all that stays the same. And so now I'm going to plug in -1. -1 squared is +1. 2 minus 3 is -1. So when x is -1, y is -1. Again, same process, different input. So, and that's how functions work. I'm going to plug in 0. That should be easy. 0 squared is 0. 2 times 0 is 0. So -3. And again, I'm thinking with this parabola that I want to find the vertex. I want to find when it starts to double back up on itself. Let me plug in 1 for x. 1 squared is 1. 2 times 1 is 2. Great, -1. So it looks like this must be the vertex because it looks like it's starting to come back up from that point. Let me plug in the 2. Hope I get a 5. And you might see right away they do get a 5 because 2 squared is 4. 2 times 4 is 8. 8 minus 3 is +5. So there's some points. So sketch a graph of this function. So I'm going to graph those points. And let me get on that. -2, 5. -2, 1, 2, 3, 4, 5. It's about here. -1, -1 is about here. 0, -3, 1, 2, 3 is down here. There it is. 1, -1 is here. Whoops, more like here. And 2, 5 is about here or so. And if I sketch that graph, it's hard to draw on this really well, but it would look something like that. So there's a sketch of a graph. And now, if I want to sketch its inverse, the inverse of this graph, I'm going to change the color so that we can see something. Let's see. Yeah, I can see that yellow. So remember what an inverse does is it flips the input and the output. So each xy pair literally switches. So if I look at this point right here, this is the point -2, 5. So the inverse would have a point at 5, -2. So 1, 2, 3, 4, 5, -2. It's right here. This point -1, 1. If you switch the x and the y, that's still at -1. I'm sorry, -1, -1. Still there. So that would be here. 0, -3 would have a point at -3, 0. Oh, that's wrong. I graphed that point wrong. I hope that you caught that. That is not a point on this. -1, -1 is actually here. 0, -3 is 1, 2, 3 is here. 1, -1 would become -1, 1. So that's here. And then 2, 5 would become 5, 2, which is here. If I sketch that, it's going to look something like that. So there is a sketch of a graph and a sketch of its inverse right here. Again, the way that we did is we sketched it and then we literally switch the x's and the y's. Inputs and outputs switch.